In this video, I'm going to explain to you the difference between a perfect square and a non-perfect square. And we're going to do this by just looking at some examples. So let's start with this first example. Is the number under the square root symbol a perfect square or non-perfect square? So I've already talked to you about perfect squares. Perfect squares are the results of an integer being multiplied by itself. To determine this, you can use your knowledge. You have memorized perfect squares up to 20 times 20. Or you can type this into a calculator. When you type it into a calculator, if the result is an integer, the number under the square root is a perfect square. If the result has a decimal other than 0, so like basically when you see it, it'll go on forever and have no pattern, then the number under the square root is a non-perfect square. So let me just start by reviewing the perfect squares. So I've taught you that 1 times 1 gives you the first perfect square, 1. I guess we've also included 0. 0 times 0 is 0. 2 times 2 we get 4. 3 times 3 we get 9. 4 times 4 is 16. 5 times 5 is 25. I'm writing the perfect squares. The perfect squares are the results of the integers being multiplied by themselves. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 we get 100. 11 times 11 is 121, 12 times 12 is 144. I'm hoping that you've practiced this so much that you can do the same thing, just create a list. 13 times 13 is 169, 14 times 14 is 196, 15 squared is 225, 16 squared is 256, 17 squared is 289, 18 squared is 324, 19 squared is 361, and 20 squared is 400. So those are the perfect squares. So this number, 1, is actually on our list. So when I said to determine this you can use your knowledge, basically I'm saying think about the perfect squares you memorized. Is 1 on that list? And 1 is on that list. The other option is go to the calculator and just type in the square root of 1. And if you get an integer, look, I got 1, then this is a perfect square. And I'll show you what it looks like when it's a non-perfect square. Let's just keep going and looking at the other examples, and this will make more and more sense. So that, the number 1 is a perfect square. Because 1 times 1 gives you 1. An integer multiplied by itself gives you a perfect square. Is the number under the square root symbol a perfect square or a non-perfect square? Well, if you look at the list back here that we made, is 2 on this list? 2 is not on this list, so it's not a perfect square. In fact, 2 would fall between 1 and 4, the perfect square 1 and 4, but 2 is not a perfect square. The other way you can tell is this. Let's go to the calculator, and we'll type in the square root of 2, and look, we don't get an integer. Look, there's a decimal attached. It's not just 1, it's 1.41421, and you're going to have to trust me that this number goes on forever. So there's no pattern in the decimal and it goes on forever. So this is, the 2 is a non-perfect square. And when you take the square root of a non-perfect square, you're going to get a decimal expansion that goes on forever and has no pattern. So 2 is a non-perfect square. Alright, is this number under the square root symbol a perfect square or a non-perfect square? So basically, is there an integer you can multiply by itself to get 42? So when we're showing our work, just think about around 42. 6 times 6 is 36, 7 times 7 is 49, and we don't have to go any further. 42 falls between the perfect squares 36 and 49. 42 itself is not a perfect square. And when we type in the square root of 42, look what happens. The decimal we get a decimal expansion that has no pattern and goes on forever. So 42 is a non-perfect square. So non-perfect square, and then we move on. The square root of 225. All right, well, if we look back at our list, I hope you remember that 225 is on the list. 15 times 15 is 225. So we wouldn't have to type it into the calculator. But if we did type it into the calculator, look what happens. The square root of 225 gives us an integer. And I know the calculator only says 15, but the answer is 15 or negative 15. Just like the square root of 1 really equals 1 or negative 1. We don't want to forget that, even though the calculator hasn't been programmed to put both answers. Okay, so this is a perfect square because you can multiply an integer, 15, by itself, 15, to get this as a result. All right, and then is this number under the square root symbol a perfect square and non-perfect square? Well, think back to our list. 336. Okay, 336 would be between 324 and 361, but it is not on our perfect squares list. So 336 is not a perfect square. Or 337, sorry. I didn't mean to say 336. So it's a non-perfect square, but just to check our work, the square root of 337 is equal to 18.35755,975, and this decimal expansion actually goes on forever and there's no pattern. So if it's a non-perfect square, it's going to produce a value that has a decimal that goes on forever. And the idea is that you're asking yourself what number multiplied by itself gives you 337. So if I pull that answer down here and I square it, look, I get 337. But this is not an integer multiplied by itself. To get a perfect square, it has to be an integer multiplied by itself. And remember, an integer doesn't have a decimal. In summary, if you take the square root of a perfect square, you will get an integer. If you take the square root of a non-perfect square, you're going to get a value that has a decimal expansion that goes on forever and has no pattern. You could also think of it the opposite way, where you say, well, an integer times an integer gives you a perfect square, and a number with a decimal times a number with a decimal will give you a non-perfect square.